naked eye. Like if you want to see the human hair, one particular hair, you need to do the magnification with microscope. We have electron microscope. And other things can be seen with the eye
Eso es más
up to
como,
10,000 nanometers.
eso es más
¿En qué
como
examen?
peruano.
¿En qué
Eso es más
examen
como
química?
peruano. Ese loco es más peruano que indio, hermano. Yo te lo digo al tiro.
And
Ah, él fue.
bacteria cannot be seen with the naked eye, only with the microscope. Then you have things in nanometer scale. For example,
¿Qué
cellulose,
pasa?
DNA, our DNA, then
Bruh.
hydrogen atom. These are in nanometer scale.
Oh, esto es humillante. Esto es humillante.
So
Esto es...
the DNA is about 2 nanometer and hydrogen atom is about 0.1 nanometer. So you can see how small nanometer is compared to human being 2 billion nanometer and DNA 2 nanometer, hydrogen atom 1 nanometer. You must have seen about Buckifall, that is called Buckminster fullerene, C60. It consists of 60 carbon atoms. It is only 1 nanometer in size. And similarly, the diameter of carbon nanotube. You must have heard of carbon nanotube. Carbon nanotube is made of only carbon, one layer of graphene, which I will explain later. You know, carbon has 6 atoms and forms a layered form called a graphite. One layer is called graphene, and this is a carbon nanotube made of carbon. The width diameter is 1.3 nanometer. So this is how small a nanometric system is. Why we are going for the nanometer scale materials are, the materials in nanoscale exhibit different properties than the bulk material. One such is surface to volume ratio. If surface to volume ratio is increasing, which means the activity will increase. We can now see here 1 cube, 1 centimeter length, breadth 1 centimeter, height 1 centimeter. So the area is 1 centimeter, 1 into 1. The volume of the cube is 1, 2, 3, 4, 5. It has 6 sides. So 6 into 1 centimeter, 1 centimeter cube. So if we find out the ratio between surface area to volume, it is 6 divided by 1. And if you take 2 centimeter cube, it can be okay. So I'll inform why I became a researcher. I completed my bachelor degree in chemistry and education, and I was working in a high school teaching English and chemistry to the students for about 5 years. Then I was motivated to do my research. During my bachelor's degree in chemistry, I wanted to do research in nanotechnology in 2002. So at that time, nanotechnology was a new field, and I gathered many material. Not many material was available for nanotechnology. I had to go to different places. Then I gave a seminar during my college days in my university. Then many of my professors suggested you go for a research, but I couldn't go. I was into school teaching for 5 years, teaching science, especially chemistry. Then later I realized that I should go for a research. Therefore, what I did, I quit my teaching job. I went for masters in nanotechnology and chemistry. Then I went to South Korea for my PhD, and I did my PhD in solar cells. So that is how I had interest for research, and I chose to do research. Now I would like to do research and do teaching. So that's what I'm aiming for. Coming back to this, if you take a cube of 2 centimeter size, the area of one side is 2 into 2, 4 centimeter. Area of the cube is 6 into 4 centimeter. That is 24 centimeter square. And if you look at the calculate the volume, it is 8 centimeters cube. 2 into 2 into 2, 8. So if you go for surface area to volume ratio, 28 by 8, sorry, 24 by 8, that is 3 by 1. And similarly, if it go for 4 centimeter cube, it is 96.64. It is 3 by 2. So when the surface area to volume keeps increasing, the nanomaterials they have more activity. This is one example. I will tell you from the day-to-day example. This is a bread pan. If you keep the pan on a table, you can calculate the area it occupies, length and breadth. Very small area. Suppose I cut this pan into slices. One slice will be like this. This is like one slice. If I cut this into slices and spread it on the table, then it occupies more areas. It's the same bread. You see here the length and breadth, it occupies very less area. But you cut it into small pieces and spread it, you can